This is a digital SAT question about the sum of the solutions to a polynomial. In the given equation, p is a constant. The sum of the solutions is equal to -5. What is the value of p? Well, here's a formula you can remember. Remember an ax squared plus bx plus c. That's called a quadratic or second degree polynomial. The vertex is -b over 2a. The sum of the solutions is -b over a. And the product of solutions is c over a. Write that down. It's going to help you in the future. For a higher degree, if the largest power of x is to the third power of whatever the variable is to the third power, the fourth power, the fifth power, the vertex, no, you're not going to find it with that formula. But the sum is going to be negative an minus 1, it's a different a, divided by an. An on the bottom means it's the coefficient or number in front of the variable, most of the times x, that's to the highest power. And then an minus 1 is the number or variable in front of the next lowest power of x. Not the next lowest power you see, but the next lowest. So if x to the 53rd is the highest power of x, you're looking for x to the 52nd power. And the coefficient or number in front of that, I'll give examples in a second. And then this one, that shouldn't be c. Oh, well, for the quadratic, it is c. But for a higher polynomial, x to a larger power is the largest power of x, it's going to be the constant divided by an, which is the number in front of the largest power. Let me give some examples, and then I'll do this question from the SAT, because it makes it very easy. What if I had 3x to the fifth plus 2x to the fourth minus 5? And I want to know what is the, technically equals 0. What is the sum of the solutions? Well, I put the negative. The highest power is 5. Oh, by the way, for this product, it's plus or minus. If the highest power is even, if it's plus. If the higher power is minus, or odd rather, it's minus. Forgot about that part. But anyway, so this is the fifth power. I'm doing the sum first. So it's going to be negative. This plus or minus only goes for the product. I'll show you that in a second. Negative, and then I'm going to put the coefficient of the highest power, the number in front of x to the highest power. And then I want, since x to the fifth is the highest, I'm looking for x to the fourth. Well, it's there. I have one, and I see the coefficient is 2. So the sum is going to be -2/3. What is the product going to be? Well, if it's odd, it's going to be negative. Even is positive. This one has an odd highest power, so it's negative. And then I put the constant, -5, divided by the number in front of x to the highest power, which is 3. -5/3, which is +5/3. So that would be the product. All right, let me do another example. 5x to the 9th plus x to the 3rd plus 2x plus 7 equals 0, of course. All right, I want the sum. The sum is going to be negative always. And then whatever the number is in front of x to the highest power is 5. And then I want the next power down. So this is x to the 9th. I want the number in front of x to the 8th. There is no x to the 8th listed there. That means there's a 0 in front of it. And -0/5 is 0. So the sum of the solutions there will be 0. Now, if you graph this, you may not see all the solutions. You'll see the real solutions where it crosses x. But the complex with non-zero imaginary components, those ones with I in them, you're not going to see those crossing x. And they can be just a little very subtle dip or kind of twist in the graph that you may not even notice. So don't try to find them all, because if there's imaginary solutions, complex zeros or complex solutions with non-zero imaginary components, probably not going to see them. So don't just rely on that. All right, so that's the sum. What would the product be? The product would be, now this is odd, 9th power is odd, so I put negative. Then I put the constant divided by the number in front of the highest power. So the product of solutions for that one will be -7/5. I will do one more, and then I'll get to the actual SAT question. This is 3x to the 8th minus 2x to the 7th plus 6. So I do negative. The highest power is x to the 8th. I put the number in front of that. The next power down from 8th would be 7th, and the coefficient in front of that is negative 2. Negative 2/3, which is 2/3. That would be the sum. What would the product be? Since it's an even highest power, it's plus. I put the constant divided by the number in front of the highest power, which is plus 2. So the product of the solutions will be plus 2. I'll do one more just to make sure it's clear. What if I had 27x to the 5th minus 3x squared plus 7? This technically equals 0. I got to have an equation. Technically, or not technically, the sum will be negative, and then I put the 27, the number in front of x to the highest power. And then I want x to the next highest, x to the 5th, I want x to the 4th. X to the 4th isn't shown, which means the coefficient in front of it is 0. So negative 0 over 27 is 0. That would be the sum of the solutions of that polynomial. What would the product be? The product would be, it's 5, it's an odd number, so it's negative. Odd power negative, even power positive. And then I put the constant 7 divided by the number in front of the highest power, 27. So negative 7 over 27. Okay, I've given enough examples. Now I'm going to look at the actual question. In the given equation, p is a constant. The sum of the solutions is equal to negative 5. What is the value of p? All right, I want the sum. Oh, and by the way, this only works for, I think I already said that. This only works for quadratics or higher power. So when the greatest power is x second, third, fourth, fifth, sixth, when the highest power is just x or just a number, you don't do this. You can just solve it. 2x plus p, set it equal to 0. 2x equals negative p, and then x equals negative p over 2. There's only one solution to that, and that's the sum of the solutions, negative p over 2. The next one, 3x squared minus 48, it's going to be negative. The highest power is x squared. The number in front of it is 3. The next power after squared will be just x. There is no x there, so that means its coefficient is 0. So the sum of the solutions to that second part is 0. And the third part is going to be negative. 2 on the bottom, because that's the number in front of x squared. And then the next highest power of x after 2 is 1. That does have a coefficient 7, so negative 7/2 is a sum of the solutions to that one. So what's the overall sum of solutions? Negative p over 2 minus 7 over 2 equals negative 5. You can put that in Desmos and put x instead of p if you want to. I'm going to multiply everything by 2. I'm just going to do it by hand. Negative p minus 7 equals negative 5 times 2 is negative 10. If I multiply each one of those by 2, the 2's just cancel out. And then I'm going to add 7 to both sides. Negative p equals negative 3. And then multiply both sides by negative 1. P equals 3. And there's the answer. P equals 3. So remember, the sum of the solutions, when it's a polynomial of the degree 2 or higher, is negative an minus 1 over an. Negative on the bottom, on the denominator, goes the number in front of the x or variable to the largest power. On top, whatever the next power down is from that, that's the number in front of that variable power. But if that isn't shown, then it's just going to be 0. And then the product, if the highest power is even, it's going to be plus. Highest power is odd, it's going to be minus. And then the constant divided by the number in front of the variable to the highest power. And I show how to get it for this SAT and a number of examples as well.